Great. So I'm Berit Anderson, and I'm here today with 5 incredible futurists for the morning. And we're gonna talk about, each of them has a very individualized view of the future. So what's gonna happen is I'm gonna give each one of them 5 minutes. They're going to wow you. No pressure, guys. You got it. And then we're gonna move on. It's a bit like an Ignite talk, if you've ever seen one of those, except no slides, so a little bit less pressure. All right, so we're gonna start with Denise Hayward-Loa, who is the CEO of Carii. And I'm putting 5 minutes on the timer right now.
Okay.
Go.
Is this on? Yes,
it's on. You got it.
Okay, so I have really thought about this a lot, historically as well as recently last night at our session on the healthcare roundtable. And one of the things I've really observed is that the young people in this country and around the world are much more open-minded and indifferent to color and accepting and tolerant than maybe some older generations are. It's something I love seeing. I've got young adult children, and it sort of gives me hope for the future in a lot of ways. So along those lines, it just seemed to me that the most important thing we can do is educate in the right way the kids, the 5-year-olds, the 6-year-olds, and all the way through, both on wellness, on healthcare, on the climate, on all the different initiatives we as a world need to take on, because we're more likely to accomplish those things if they're educated in the right way, which is something I'm sure some of my colleagues will pick up on. But it's all about having them continue being tolerant and open-minded and accepting of diversity and accepting of the things that we need to change and being interested in changing those and being aware of how they can contribute. A lot of them, I think, don't know. And so to give them the ability to contribute, to give them the knowledge they need to contribute. So I don't think that was 5 minutes, but I said my piece.
It was a very, very, you have 3.5 minutes left. Would you like to donate?
I'll donate them.
All right. Scott.
Okay.
Scott Thorogood.
Good morning. So I'm going to talk a little bit about nanotechnology, since that's the field I'm in currently. Nanotechnology, as you know, the body moves because of the interaction of nanoscale molecules that cause muscles to contract. And so when you can introduce nanotechnology into the body in other ways, it's very effective. And we found that with our retinal implant, which is a nanoscale implant for prosthetic rods and cones. We've seen that with cochlear implants. We've seen it with deep brain stimulators, to deal with Parkinson's and so on. And it just continues and continues. So I think what we're going to see in the future are neocortical implants, which, the neocortical part of the brain deals with, higher brain function. And so can you imagine having a neocortical implant that's connected to the cloud, so that you could do all kinds of stuff with that? So now the cloud, all that information in the cloud is going to be provided to the person, consistent with their genomic makeup, talking to their nanoids or nanobots in their body that are swimming through their circulatory system, attacking cancers, destroying vascular systems that are associated with certain cancers, etc. Downloading the latest pathogenic information associated with that person's disease condition, and having really individualized medicine in a connected way. And so you can imagine that would obviously allow people to communicate that way. So imagine someone being able to read your mind. So you'd really want to have blockchain working, because you get into it, you don't have to do anything, you just have to think it, So there's a lot of things that I think that are going to occur that are pretty exciting. So delivering drugs, same thing. You got these, nanoscale robots in the body delivering drugs, targeting cells that need the drugs that are like immunotherapy, for example, targeted to that one person's disease condition, immunotherapy. Pretty interesting stuff if we can pull it all together. A lot of these nanobots or nanoids will be propelled, either inductively, magnetically, powered photonically. There's lots of ways to power things. We're powering our device inductively, wirelessly. There's a lot of ways to get these devices moving through the body, and basically repairing cells, reporting on the condition, making sure your body is always in a balanced chemistry at all times. The IoT on steroids, basically here. We're also working on nano single photon sensitivity. A person, for example, when I say single photon, what does that mean? A person who is basically dark adapted, so that you're out in the dark, your eyes are adjusted, can detect 60 photons at the lowest possible thing that they can see. We're detecting single photons, so we're applying these sensors not only to our next generation retinal implant, but we're applying it to robotics, DoD night vision, autonomous driving, low light imaging, CMOS sensors for cameras, anything that you can imagine that needs to see, and see in a single photon way based on a discovery that we made in physics that was missed for 30 years, and so it's kind of cool. So I guess, that's how I see the nanotech revolution, and it applies to all kinds of different things, but to people and healthcare and disease and imagine being connected to the cloud as a person, and what if you could store your memories in the cloud? Wouldn't that be crazy? But you never know. But we're talking about the future, which is this conference.
That's a pretty incredible vision. What's the time line for that, do you think?
You always ask these tough questions. That's a tough one. I mean, we've got the technology, okay, and we've got the quantum computing, capability, and the security, the blockchain, and we've got the cloud-based AI. But we still don't know how to read people's minds. Okay, we can't just put someone's memories up in the cloud and say, okay, now we're going to share that and apply AI to it and help them write a book. But we're moving in that direction. So I can't give you a time frame, but it's certainly a lot of the labs around the world that I'm aware of are working on it, and it's exciting because it's real.
So is it like 100 years or more like 50
No,
years
it's
or
less
10
than that.
years?
No, it's not 10 years, but it's probably 30 years.
Great.
But we're going to see incremental improvements. It's not just going to be a binary thing.
Yeah,
It's going to be incremental. I mean, the nanotechnology, the fact that you could launch a nanoid in the body and have it swimming through the vascular system, attacking certain cancer cells, is not that far away, actually, because we know how to target cells today. With certain, we can actually get, whether it's an adenovirus vector or whatever, we can actually get, certain drugs to cells today.
That's incredible. All right, Marc Prensky, you're up. Introduce yourself.
Okay, I'm Marc Prensky, Global Future Education Foundation. I'm here not to talk about education, but about kids, because often we talk about education as the system and ignore the people in it. I want to talk about kids and real-world accomplishment and passion that John Hagel talked about applied to making their world a better place. And I had this connection that I'd never made when we were talking about whales, which is very much like, kids are very much like whales in that they're under-respected, underappreciated, undervalued, and the kids around the world tell us they want more respect. You may have seen my piece that I wrote recently in Marc's newsletter about the structure of scientific revolution in Kuhn, and what Kuhn says is that when a revolution comes, it comes because there's an anomaly and something that requires us to put on new glasses to see the world. And that anomaly, in my view, is the fact that we now have empowered kids. That if you're out there looking at a group of kids, you're looking at extended brains all networked together. And we've hardly begun to take advantage of this. We're all dissatisfied with the education. You heard Dennis and everybody else screaming about that. But the only thing that people have been doing up till now is innovating at the margins, tinkering. We can add a little more technology. We can add some STEAM or STEM or social emotional stuff. But what we really need and what's emerging in the world is something different. What we really need is the fact that kids can accomplish things. And they are starting to do this bottoms up and doing essentially an end run around that terrible education that we have given them. So at the college level, you've probably heard about the the soccer balls that absorb energy that you can then reuse, or the fields, football fields turned into organic farms, or the coding that's being done by projects at École Calendu and other places. At the high school level, there are things like Patrick will tell us about the ocean debris and some of these big projects that are happening. But kids are making apps for raiding the police, for fighting bullying in very interesting ways, for measuring the lead in the Flint water, for using facial recognition to help Alzheimer's people, and even it goes down to the elementary school kids, where they are using things like iWire to help map the connectome, where they're approaching people in government to get things done that will benefit them. And so what's happened, I see this all over the world, and I've been feeling a need to unite this into a movement, because a lot of people are doing this. There's a lot of branding involved. Everybody wants their own brand and wants to say this, but we're all doing the same thing. We're all taking not an academic education, which somehow grew out, but something that's much longer in human history, an accomplishment-based education. And we're figuring out how to do this, and I am here to encourage and to work with all of you to make eventually an end-to-end alternative. We'll never get rid of the academic education. It's too entrenched, but we can have a side-by-side alternative that fits kids much better and that's equally valuable. And so to that end, I have two requests for everybody. One, if you know of anything that's happening in this field of kids inventing their own projects, doing the projects, working on them, I'd like to know about it. I have a database of hundreds of these, which is online and which you can get. And I also want to tell you about what one group is doing that I work with. There's a group called Design for Change out of India, and they've been doing projects with kids all over the world, and the person who runs this managed to connect with the Pope. So next year, in November 2019, we're bringing 4,000 kids from around the world of all ages to the Vatican, and it's going to be called, because they want to make kids get the I CAN virus, this is VAT I CAN, sponsored by the Pope, addressed by the Pope, where we're going to, and it's going to be the launching of this idea of a movement that kids can really say, I can, that they can do their own projects, that we can encourage them to do their own projects, that they don't have to sit in class and be bored, that this is equally good for parents, for the teachers who want to do something better, and especially for the kids who now feel so empowered. So if you want to be part of that, come see me. I'm happy to give you more information. Thanks.
Perfect. Squeaking in with 9 seconds left. I'm going to use a little bit of Denise's leftover time to ask you one question, which is, what do you see as the benefit of bringing all these people together? Is the idea that there will be an increased benefit for the kids, or what's the...
I see that we relieve the pain of everybody. The employers want people who can get things done, so it helps employers. The kids want an education where they really care about this and want to participate in it. It does that. There's a lot of faculty people who are interested in helping kids, very frustrated because they have to do things the old way. So I think it's a win-win-win-win-win for everybody.
So it's essentially bringing people together so that they can connect around all manner of...
It's connecting around a different vision of education in the world.
Got it. Awesome. Thanks, Marc. Charlie,
Yeah. So,
how are you?
pretty
Good morning.
good. Good morning. I was just dazzled by the future and the bright ideas that are coming out in this conference, which we decided to. I proposed a theme, called it FiRe Camp. And we can talk about that later. But I'm here to share with you my vision about the future, especially within healthcare. And I want to start by saying that it's bright. We have the potential to change the world within healthcare. And within this, I want to bring across 4 technologies or 4 aspects within healthcare that are going to revolutionize how we live, how the lifespan is going to increase. So I made a list, because as a scientist, we like to have something concrete in data. So I'm going to start by saying that medicine is shifting to a more precision-based medicine that is specific for a single individual. And that's where we're going. As a scientist, as an entrepreneur, that's what we're aiming for. So within the precision medicine, the first technology or innovation that I believe is going to change the world is digital health, right? And we're seeing it here. It is going to happen within the next 2, 5, and maybe 10 years. As Scott said, things don't change drastically. They change by steps. And we start seeing voice recognition, right? Imagine an Alexa, a Google-like system that the doctor can use so he can actually record and provide information to the EMR system. So he doesn't have to spend all the time looking to the screen and typing and trying to understand you, where the average visit is only 25 minutes. Within those 25 minutes at the clinic that you spend with the doctor, around 15 of them is him typing in front of the computer. He got a left of 10 minutes to diagnose, detect, and provide you health. We need to change this. So I believe that voice recognition could be a potential way to do this. We have the systems, we just need to incorporate them, and we're gonna see this in the next couple of years. So that was the first within digital health. The second one is the application of artificial intelligence, AI, within allowing us to understand trends, these patterns. What does that mean? We're collecting all this data. How we can create a system where we can identify hotspots that medicine can target, precision medicine. The next one is VR, AR, right? Imagine a world where the doctor has a headset that he's seeing your spine without opening you and understanding all the subsystems and systems within your body, because we all know that we are a complex system. And understanding all this and being able to really target what he was looking for. This is what we're gonna see in the future, guys. It's bright, we're moving forward. So this is within the first bullet point. The second bullet point that I have is robotics and health, right? Imagine the assistant of a robotic arm, the third arm, or even the fourth arm in an operating room, right? Imagine a robot that can help you with care. You don't have to hire a nurse. Imagine that. It is a beautiful, bright future. Nanotech. We talk about nanotech. I think Scott covered a large majority. This is going to change the world. The way that we can release drug at command at the nanoscale. Nanoscale is a billion. If you get a meter long, you can break it into a billion times. That little tiny piece that you collect, that your naked eye won't be able to see, that's a nanoscale. Just want to give you a frame of reference. So imagine that we're able to build these capsules that can release drugs in command by sending an app. The doctor sends you the prescription, you ingest it, and you can release it as a function of time. Imagine that you can target the area that you want to target, precision medicine. Imagine that you can repair tissues, create new organs, or repair the organs that are damaging. This is where we're going in science and in health. The next one, which is the last point that I want to bring across, is the next generation of diagnostics, right? We start hearing about genomics, immunoassays. These systems and these specific diagnostics for each person is changing as a function of time. It's going to get cheaper. It's going to become the standard of care. We're seeing it with the Apollo project, right? This is stuff that is going to help us to live a little bit longer so we can change the world in other aspects. That's where I spend my time, right? Control and understand of medications. We're prescribing antibiotics. We all know this. We don't have the tools, the clinicians don't have the tool to diagnose whether the antibiotic is actually needed. They cannot differentiate in some cases about, is it a viral infection or is it a bacterial infection? Imagine that happens with your kids. This is a big problem, guys, that we scientists and engineers and entrepreneurs are trying to change. And the last point that I want to say here is the connectivity between wearables, the data in the cloud, and the connectivity to the EMR systems. The doctor being able to collect and understand what that means, and having, AI, nanotechnology, all combined into this future that is going to change healthcare. And I'm just going to leave that.
Thanks, Charlie. That's very wide-reaching and very compelling. It's very cool. All right, Patrick Hogan, you are up, And then we're going to have a couple of minutes for questions. So as Patrick is wrapping up, if you want to ask any of these guys questions, some really kind of incredible forward-looking perspectives on stage here, just come up to these microphones over here.
So Scott, could you roll it? Thanks. How can we advance? I just got to say something. Thank you. Push the green button, I suppose.
Yep.
Okay. If we really want a future, I suppose we do. There's two maxims I will suggest that we need to live by. And one is minimize pain, obvious, duh. The second I will suggest is to maximize education. We're talking about youngsters here, like the primary school kids. Both of these folks mentioned that. I think this is important to recognize that we do not encourage them to their potential. You look at any 5-year-old, anywhere on the planet, they're not walking from point A to point B. They are dancing. They're doing everything but walking in a straight line. They're all over the place. Their eyes, their ears, their body movement, Try walking like that and see what it does to you. It really opens you up. So you can learn a lot by watching a 5-year-old and do something really constructive with it. So the two maxims, minimize pain and maximize education. So right now, I've been managing a program called NASA Whirlwind. It was there before Google Earth, but essentially it's Google Earth. We like to say Google Earth on steroids. And just a small note, the last talk involved nanosatellites and satellites in general. If you go to GitHub, a place called Whirlwind Labs, I had an intern 2 years ago build an application that shows all the satellites. Every satellite's out there right now, around somewhere under 20,000 of them, including the space junk. And you can see them by year was launched, meta information's all there. You can see when it was launched, what orbit it's in, by what orbit, but all kinds of things. Anyways, GitHub, Whirlwind Labs, and this particular app is open source. It's called Space Birds. So we're doing some work for the UN with students, inspire them to do phenomenal things for the planet, and these kids wake up and rise to the occasion. So I'm going to show you how that happened. And NASA Whirlwind is now no longer NASA Whirlwind. It is now ESA NASA Whirlwind. The European Space Agency has standardized on it. They're coordinating with the NASA team, and that's how Whirlwind continues to be developed. Where are we? This is us. We're somewhere in here. Oh yeah, Milky Way. You are here. If you want to continue being here, we're going to have to change the game plan. Right now, we're not on course to stick around. It's a nice place. Be nice if we could keep it. Little Shakespeare for us. Either the top line, a bit of Romeo and Juliet tragedy, or Miranda's hopeful look into the future. Nice place. And boy, is there such tenderness here. So let's maximize that somehow. But, what are we doing? Like rock stars, we're the most recent species here just about. We just got here a couple 100,000 years ago at most, and we've already trashed the joint. This kid needs to be in a classroom, not out here collecting straws. I'm part of a group. There's a website called Scientist Warning, and I'm on the advisory board for that group, so I'm obligated to mention it. If you go there, you'll get a little information about the state of the planet. I just did a web page for this on meat. I was blown away by what I discovered. The meat industry, including the agriculture that's grown to feed that and the transportation involved, half of the carbon, the greenhouse gases we got on this plant are a result of the meat industry. I just couldn't believe that, but if you go there, you'll get that information. NASA Whirlwind can do just about anything. You can see things in 2D, 3D all at once, going straight in on the model, and just picture the technology. You can get up close and do stuff as well. So what I'm going to just mention here real quickly, and this is going to blow through these also, is there's an enterprise called A World Bridge. If you go to the website called aworldbridge.com, There's a gentleman who was the NASA teacher in space astronaut. And if Christy McAuliffe hadn't gone up, he was going up. Instead, he didn't, and we still have him here, thankfully. He is building process education, real-time, real-world applications that students are being inspired to build results for. One of them, City Smart, we call it City Smart Worldwide. Here's an entire grid. The Kodiak, city of Kodiak, they got 2 hydro plants. All the information on the construction of those things is now open and available to the public. They have 2 wind turbine farms. All that's available to the public. And then the entire grid for that going from those power generation points through every pole throughout the city. This is an open source application that any city can begin using, and we're working with the city of Springfield. They're using pieces of it, and we'd like to get the world coordinated around urban management application that all cities can share so we can start realizing, hey, we're in this together. We need to do the same things. Why are we doing this independently? And who will build those things? But students, if they think they're doing something for the community and the planet, they go absolutely ape in terms of productivity.
So Patrick,
Here it is.
This is incredible, but as your official timekeeper, I have to tell you.
I'm where?
You're 30 seconds over.
Okay, I'll go through this real quick. This is some of the stuff that they're doing with UAVs. They've actually mapped the entire Kodiak launch complex, which had a major accident. This is the invasive species work they're doing for the UN. The kids won an international award for the application that they built. So that's how effective it is. It's being used by the UN FAO right now. Same now with USGS, they have their data portals. They feel like they're not doing a good job. So the director of the Innovation Center for Earth Science at the USGS now has a World Bridge students redoing the USGS portals for about a dozen of their portals. These are kids, high school kids and university students doing this. Rather inspired. This last note I really want to make a point out of. These kids have taken magnetometer and maxed it to something that has never been done before. They were recording the magnetic field at 250 hertz. They've settled it down to 50 hertz. And this is in Alaska, and we're collecting data 50 hertz. That means 50 times a second. And we have found that in the 3 days before an earthquake, the magnetic field anomaly goes wacko, but it does it on short order, so you got to be listening carefully. And the XYZ anomaly of that event points directly at the source. There's a major energy point that's going on there, so those spikes are happening, interrupting the magnetic field. If you're listening, the XYZ anomaly of that magnetic field points right at it. We can predict an earthquake before it comes. Can't exactly say exactly when, but we say, hey, something's about to happen.
All right, I'm sorry,
That's
but I'm gonna have to cut you off. We have one question. This is incredible. That was it. That was pretty good. Okay. Roger.
This is just a comment on Scott Thorogood's fascinating speech, which is there is a guy named Jorge Reynolds in Colombia who's one of several people who were the earliest discoverers of the pacemaker. He has now got clinical trials going on pacemakers that are the size of rice grains, and these rice grains are injected into the pericardial cavity, and the pressure of the heart against the pericardium is what provides the energy to run these things because they have a piezoelectric crystal in them, and the pressure runs just enough power to be able to provide heartbeats and a complete pacemaker. And this whole thing, as I said, is in clinical trials, and they will be put into person not by an operation, but by simply a hypodermic.
Thank you. I'm going to check into that.
That's amazing. All right. Well, any more questions? Oh, sorry.
Yes.
I can't see you.
Am I
I'm blinded
on?
by
Okay.
the light, literally.
Oh, great, no problem.
Last question. We've
yes.
got 8 seconds.
8 seconds. Okay, so Peter Thiel had this question to people that, tell me something you believe that most of the people that you know don't agree with. So there seems to be some kind of conformity when it comes to the futurist community in general. I would like to know what you guys believe, what you guys feel or doubt that is counterintuitive to what, to most of the things that have been told at the Future in Review conference.
Okay, we're already over, so we need one word. Anyone have one word answer to that? Marc.
Our kids are much more powerful than we think, and we really need to trust them and empower them. and they will solve a lot of the issues that we have.
Bingo.
That's
Okay.
great.
That's
All right,
powerful.
guys, thank you so much. These are incredible.